Hello everyone. This video would focus on conic section, specifically on ellipse with center at HK, and this is the second part. In this part, we are given the general equation of an ellipse, and we're supposed to determine the case number, the center, the foci, the vertices, and the co-vertices, and we're supposed to sketch the graph of this given ellipse. Before we go over this example, let's have a review on the parts of an ellipse and the two cases of an ellipse with center at HK. Please remember that these are the parts of every ellipse. The first part is the center. For this case right here, this is not at the point of origin. Our center is at HK. This coordinate HK is the reading along the x-axis that is represented as the H, and the reading on the y-axis is represented as the K. Please remember that the center is the midpoint of the major axis. It's also the midpoint of the minor axis, and it's also the midpoint of the foci, the two foci. Another part is the major axis. The major axis is the longer diameter. This is the line segment that connects the two vertices passing through the center. So on both ends of the major axis is the vertex. A vertex is the endpoint of the major axis, and there are two of them. So we call them as vertices. Another part is the minor axis. The minor axis is a line segment that connects the two co-vertices passing through the center. So the endpoints of the minor axis is a co-vertex, and there's going to be two of them. We call them as the co-vertices. So by definition, a co-vertex is the endpoint of the minor axis. And again, there are two of them. Another part is the focus. We remember that the coordinate of the focus for this case, which is the horizontal ellipse, is represented as H plus minus C comma K. So this is the coordinate of the focus, again, for the horizontal ellipse. We remember that the distance from the center to the vertex is represented as letter A, while the distance from the center to the co-vertex is represented as letter B, and the distance from the center to the focus is represented as letter C. We also remember that the formula for a horizontal ellipse is represented as quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. Now, please notice that the value of a is under the quantity x minus h squared. The reason for this is because it is a horizontal ellipse. Horizontal means left and right, so the a will be under the x. Now, we also remember that the value for a is always greater than b. And the equation that relates a, b, and c is c squared equals a squared minus b squared. Now, let's look at the second case of an ellipse. The second case of an ellipse is the vertical ellipse. We pretty much have the same parts. We have the center. We also have the major axis. We have the two vertices. We also have the minor axis. We have the two co-vertices. We also have the two foci. Now we remember that the coordinate for the focus of a horizontal ellipse is h comma k plus minus c. Now we also remember that the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is letter B. And the distance from the center to the focus is represented as letter C. Using all these values, we remember that the formula for vertical ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Now we remember that our a squared, which is the greater value, is placed under quantity y minus k squared. The reason for that is it's because this is a vertical ellipse. We remember vertical, that means it's up or down. And so this is placed under the y. And we also remember that a is always greater than b. And the formula that relates these lengths A, B, and C is C squared equals A squared minus B squared. So these are the parts of every ellipse, and these are the two cases of every ellipse, the vertical and the horizontal ellipse. Okay, so we go over the problem here. We are given this equation, 9x squared plus 64y squared minus 36x plus 384y plus 36 equals 0. Now, looking at this, we don't know what the a value is, what the b value is, and we don't know the center of the ellipse. What are we going to do is we are going to change this to its standard form. In order that we can do that, the first step is to isolate the constant, which is the 36, to the right side of the equation, and we group all the x's. This means that this equation would come out, so we group all the x's first. So the x's would be, the ones that contains the x on them. So that is 9x squared. We also have a minus 36x. So those are the x's that we have. Then we put together all the ones with y. So that is 64y squared. And then we have a plus 384y. And then we are going to put the 36 to the other side of the equation. So pretty much we have to subtract 36 from both sides, minus 36. And so our equation comes out that's going to be equal to negative 36. Now, what are we going to do next is we are going to factor out the 9. So we're left with just x squared. So factoring out the 9, so it's like we're doing the distributive backwards. So I put the 9 outside parentheses. So that is x squared. So 9 times x squared is 9x squared minus, this is gonna be 4x. So that if I have 9 times negative 4 is negative 36x. And then I will also have to factor out the 64. So that would be 64 then y squared plus, in 384, there are 664. So I can go ahead and write 6y, so that if I have 64 times y squared is 64y squared, 64 times 6y is 384y. And that is again equal to negative 36. Now, what are we going to do next is we are going to add blanks after this 4x and after the 6y. So this equation would come out. So I added blanks to the first parentheses and I added blank to the second parentheses. Since I added 2 blanks on the left, I will add 2 blanks on the right as well. Now, what do we write into this blank? So we go ahead and look at this value on the middle term right here, which is negative 4. So I write negative 4. We always divide this by 2 every time. So negative 4 divided by 2 is negative 2. So I'm going to go ahead and write right here. So negative 2. And then we are going to square it. So negative 2 squared is, whatever the answer to this, will be the one that we write here. So negative 2 squared is a positive 4. And so I will do that on this other side right here. So we are going to look at positive 6. And so we always divide it by 2 every time. So it's positive 6 divided by 2 is positive 3. And so whatever that value is, we are going to square it. So 3 squared, whatever the answer is, that's the one that we write here. So 3 squared is 9. So I write that down there, that's 9. And so I will also have to write or add the 2 numbers right here. Since this is 9 quantity 4, so that would be 9 times 4 is 36. And we also have 64 times 9 is 576. So I go ahead and simplify this. Now, looking at this, this is already a perfect square trinomial. So I can go ahead and write this as 9. There's going to be 9 right there. And this is a perfect square trinomial. This is x minus 2. Now, what is the easiest way to rewrite this? Whatever is this value right here, that's the one that we pair up to here. So, or we can just go ahead and use the box and diamond for this. That should still work, but that's the fastest way to do it. And then that is plus the other one right here, that would be 64. And again, this is a perfect square trinomial, and this is actually y plus 3. Again, in order that we can, the fastest way to do that is whatever this value here, that's the one that we write down here. So that is y plus 3 squared. And this is overall equal to 576 because we have negative 36 plus 36 plus 576. So that is 576. Now, since in the standard equation of an ellipse, the right side should be equal to 1. This means that we are going to divide 576 to both sides of the equation. Okay, dividing 576, this will give us 1 right here. Now, looking at this, we can go ahead and say that this becomes a 1. So there's 1, 9 in 9. And there are, that's gonna be 64 9s in 576. So we're pretty much reducing it to lowest term. And there's 1 64 in 64. And there are 9 64s in 576. So what I did was I reduced this into lowest term. So our equation would come out quantity x minus 2 squared over 64. And that is plus quantity y plus 3 squared over 9. And that is equal to 1. So we already have the standard equation of an ellipse. So I'm going to go ahead and put this inside the box. Okay, we remember that the bigger value represents the a squared. This means that this is our a squared and this is our b squared. This tells us that if we have an a squared of 64, this tells us that our a then is plus minus 8 because we squared both sides. Square root of 64 is plus minus 8. And if we have a b squared of 9, and so we can go ahead and say that our b is plus minus 3. Now, looking at this, we can go ahead and say that this is an example of a horizontal ellipse because this, again, this represents our a squared and this represents our b squared. Our a squared is under the x, and so this is a horizontal ellipse. So I'm going to go ahead and write it up here. Now, the center for this ellipse is the HK. Remember, it's these two right here. So we can go ahead and remember we have to switch and switch. So then our center here is positive 2 and negative 3. And so I go ahead and plot the center here. So that would be on 2 and negative 3. So it's right here and negative 3 down here. So this is our center. Now, we remember that this is a horizontal ellipse. That means we go left and right 8 and 8 because, again, that's a horizontal ellipse. So we go 8 to the left and 8 to the right, and we are going to go up 3 and down 3. So I will put those dots here. Okay, so I've drawn the ellipse and determined the coordinates of the two vertices and the coordinates of the two co-vertices. Now, we are going to determine the location of the foci. Now we remember that the location of the focus is c distance from the center, and the formula that we're going to use to solve for c is c squared equals a squared minus b squared. So I'm going to go ahead and show that work up here. So our focus is located 7.42 from the center and 7.42 on the other side. So this would be 1, 2, 3, 4, 5, 6, 7.42. So it's somewhere around here. So this is our first focus, and the other focus would be across 1, 2, 3, 4, 5, 6, 7.42 is somewhere around here. So this is our second focus. Now we determined the coordinates of these two foci. Now we remember that the coordinate, since this is a horizontal ellipse, the coordinate of the two foci would be h plus c comma k and h minus c comma k. So it's pretty much the same thing as this, but since this is horizontal, we are going to add the c to the h. So our coordinate for the first focus would be, that would be 2, and we're going to add this one. So 2 plus square root of 55 comma k, which is negative 3. And the other coordinate of the focus would be the same thing, 2, but this time around we minus the c, which is square root of 55, and then the k, which is negative 3. So these are the coordinates of the two foci. Now we determine the length of the major axis and the length of the minor axis. So I'm going to go ahead and write that up here. So this is the standard form of this general form of an ellipse, and this is the graph of these two equations. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're given this general form of an ellipse. So what we would do is we are going to group together all the x's. So these two x's right here, we're going to group together all the ones with a y. And then we are going to isolate the constant on the other side of the equation or on the right side of the equation. So this equation would come out. Okay, so what we do next is we are going to factor out 81 from this expression right here and factor out the 25 from this expression. So this equation would come out. Okay, now what we do next is we're going to add blanks to this quantity right here. So this equation would come out. Okay, now we remember that the one that we write into the blank here is we are going to divide this middle term by 2 and then we square it. So I'm going to show the work down here. So the one that we write on the first blank would be 81 times 16, which is 1296 or 1296. And we have 25 times 1 is 25. So then we go ahead and simplify this further. So this would come out 81. Again, this is a perfect square trinomial. That would be x. And the easiest way is this one will pair up to the x. So that would be a plus 4. And then squared, and then that is plus the other one right here is the same thing. So we have 25. This is a perfect square trinomial. That is y minus 1. Again, we got the minus 1 from here. We can go ahead and put that down here. And then this is squared, and that is equal to, if we add all of these, this will come out 2025. So we are going to divide 2025 to both sides of the equation so that we can come up with 1 on the right side, and the equation would come out. So this is the standard equation for this general equation of the ellipse. So looking at this, we can go ahead and say that this represents as our a squared and the 25 represents as our b squared. Now notice that our a squared is under the y. So this is an example of a vertical ellipse with center at -4, +1. I'm going to go ahead and write that up here. Okay, this tells us that since our a squared is 81 and our b squared is 25, we can go ahead and say that our a then is ±9 and our b is ±5. So I'm going to go ahead and write that up here. So we go ahead and plot the center, which is at -4, 1. So that's -4 and +1. So this is our center. And our A is ±9 since this is a vertical ellipse. So we go up 9 and down 9. And then for the B, we go left 5 and right 5. And I'm going to go ahead and plot those 4 points and write the coordinates of the vertices and the co-vertices. Okay, now let's determine the location of the two foci. We remember that we can solve the location of the two foci since it is located c distance from the center. And so we can use the equation c squared is equal to a squared minus b squared to solve for the location of the two foci. So I'm going to go ahead and write that work up here. So the two foci are located 7.48 steps up and 7.48 steps down. So I'm going to go ahead and plot those two foci up here. Okay, since this is an example of a vertical ellipse, the coordinates of the two foci for vertical ellipse would be h, k plus c and h, k minus c. So it's pretty much the same thing as this, but we are going to add and subtract the c from the 1. So I will have to go ahead and write this as -4, and then that's 1 plus this value here, 2 square root of 14. And the other coordinate would be -4, 1 minus 2 square root of 14. So it's pretty much the same thing as this, -4 and 1, and then -4 and 1. But we have to add and subtract the value for the c. Now let's determine the length of the major axis and the length of the minor axis for this ellipse. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!